Let's do one more full example of a robot specified in DH notation. So another DH example. And here is the specification of the robot. So what do we notice just by looking at it compared to the previous robot that we've looked at? For joints, we have a first transform that's fixed. So the first row has no joint variable in it, right? So we have a row 0, which means from the base to the first joint, we have a link. So that's just a robot where we've decided by convention that our base coordinate frame is not at the first joint. So we have a fixed link in between, which is always possible. 4 joints, 3 of them are revolute joints. 1 of them is a prismatic joint. So let's sketch this robot. Let's see what it looks like in space. We're going to have a base coordinate frame. X, B, Z, B. So this is the base coordinate frame. I'm not going to draw the x-axis just for clarity. Okay, so the first row of our table, just a fixed transform, no rotation around Z, 0.5 translation along Z, which brings us, let's say, 0.5 up to here. 0 translation along X, 0 rotation around X. Okay. So the coordinate frame for our first joint is up here. So there is a fixed link that gets us from the base coordinate frame to the first joint. Okay? So this is the first, this is L0. Okay? This row, our joint is, so we have a rotation by Q1 around the Z-axis. So let's move this X0 here just for clarity. Okay, so if we extend this a little bit, then we're moving like this. Okay. We have no translation along Z. Okay, we have 0.7 translation along X. We've rotated X by Q1. So we have a translation along X by 0.7. So let's say that 0.7 brings us to here. And then we have 0 rotation around X. So we're done with that row. We can go ahead and draw our coordinate frame. So this is going to be X2, X1. This is going to be Z1. And we are done with this row of the table. The next one, we have, again, a rotation around Z. Just for clarity, I'm going to draw it going back towards the original axis. So if we extend this a little bit, right, a positive rotation around Z will bring X into Y. So this is actually going to be a negative rotation. So this is minus Q2. But this will just make it easier to draw. Okay. Then we'll have 0 translation along Z, 0.7 along X. So that'll bring us somewhere, let's say, over here. And we have our next coordinate frame. So X2, Z2. And we're done with this row of the table. Now we go to this row. This is the prismatic joint, so we have 0 rotation around Z, but we have a translation along Z. Again, a positive translation would be moving up. I'm going to draw it pointing down just for reasons that will become clear in a second. So this is a prismatic joint. Okay, so then this distance is going to be Q3. And we have no other component. There's no translation along x. There's no rotation around x. So then x3 just points like this, and z3 points up. And then finally, the last joint is, again, rotation around z by Q4. So this is going to be x4. z3 is the same as z4. It's unchanged. And this is Q4. OK, and we're done. If we were to sketch an end effector, then the end effector would maybe look like this. And again, I mentioned that a positive translation is obviously along z2 is going up, so this is a negative translation. So this is so this is a negative translation. And now you can get a sense for what this robot looks like in space, right? Up to here, it's just the simple robot that we've talked about in the past. So imagine two links, the two parts of my arm. So the robot is moving like this. It has 1 degree of freedom here around the vertical axis, another degree of freedom here around this vertical axis. The base is down at my hip, so down here. So this is what the robot looks like. But then from here, it also has an end effector that can move up and down, and then finally rotate. So if we go back to the computer for a second, this is another sketch. Obviously, it's the same as this, except that this one is a little easier to interpret, because now you have the links of the robot also drawn. So you can imagine that this robot, right, this bit right here, this part, moves up and down. The end effector can rotate around the vertical axis. So what this robot can do is it can pick things up. If you imagine this plane right here, so the plane of the base, for example. This robot can go ahead and pick up objects that are sitting in that plane, because it can move the end effector up and down, and it can also rotate the end effector, and it can easily pick things up that are sitting in the plane of the base. So this type of robot is actually referred to, as you see here, as a SCADA robot. It's a very common kinematic arrangement. You can look it up, and you'll easily find videos of this robot in operation. And very commonly used pick-and-place robot for moving things around in the plane, right? So this sketch that we just drew by hand, same as this one, except that this one also shows the links sketched a little bit better, so you can get a sense for what this robot is used for.